Kapow! Hey, welcome to the show. It's me, John Park. You are here with me for a little bit of a show that we like to call JP's Product Pick of the Week. And that is exactly what we're going to do. We've picked a product. It is a brand spanking new product. I don't think we've ever done a newer one than this on this show. I think it's the newest, latest that you can possibly buy on the Adafruit site. I'm going to double check that. Is it? Is it really? What's new? Yeah, that's right. There are a few listed newer that you can't buy yet, but this is it. This is the top one on the list. It's a bit of a hint in case you've been watching the new product page. You may know what I'm talking about. But what's going on here? Well, what I like to do is send you there. If you'd like, you can head on over to the product page. That's it. Product ID right there, 5993. You can go check it out in advance, but you won't even miss this show because it's going to take place right inside of the product page. We have it streaming right inside of there. This is redistributed into the product page, just like a magical moving catalog from the wonderful world of Harry Potter or something like that. But you can check it out. You can get it at a discount, but you can even stay tuned one moment longer and have Lady Ada actually describe what the heck this thing is. So please take it away, Lady Ada.
Next up, a Type-C downstream vertical port. So we have the horizontal port in stock. People really love it. But maybe you want to go topside. So this one has the port sticking up. So it's a little bit of a bigger breakout because we have 2 rows of header to make it mechanically strong. But great if you want a port to stick up. So if you want to mount this on something, you have 4 mounting holes so that the port can stick up through an enclosure. So maybe I'll show it on the overhead real fast because it's a very easy to demo. So I put 2 strips of header. They're the same pins, and then you get all of the I/O. You get the 2 CC pins, the 2 SB pins, data minus, data plus, VBus and ground. So there's 2 5.1K resistors here, which means by default the VBus is going to give you 5 volts. But if you want to hook this up to a power delivery chip and negotiate higher voltages, you can totally do that. It's just set up for downstream 5 volts. So by default, you want, like I was just showing, the IR breakout board. This is just connected to a USB power supply. I can connect this up and it's instantly powered because I don't have power delivery, so I get the voltage out. Some USB-C power supplies will not do it unless you have the resistors, so those are handy. And I don't know, nice vertical style. A nice strong connector too. I picked a good one. Sorry, Liz picked a good one. And this is designed by Liz, so she this is her first PCB design for us. So Blitz City is learning how to do EagleCAD, and we were using this part for another project, and I was like, let's design a breakout, and that's what she came up with.
Yes, it is. That is indeed it. And I'm going to ask a question before I move forward, which is the echo gone? Debo Dog in the chat said they were hearing an echo, and I'm not sure when that was. So sorry about that. If you were, and hopefully it is no longer. So I'll wait a moment before I launch into the rest of the proceedings to double check that our audio is good. If it's not, then I've got some troubleshooting to do. So let's have a look here. Anyone? By the way, in the meantime, I will say thanks for stopping into the chat. We got Dave Odessa over in our YouTube chat, in our Discord chat, which is this right here. We got Debo Dog who says, okay, good, thank you. No echo on YouTube, says Toddbot. Hello, squid.jpg, Uniscu7. Starman said, I'm not showing on YouTube. Oh, that's weird. Was that before, during, after, now? Hello, Rufus. Hey, Liz. Appropriate that you're here, Blitz City DIY. This is your design. Very cool design. Okay, I think we're good to go. Thank you. And let's do this. So that's a little sneak peek of it right there. And this right here is my product pick of the week this week. It is the USB Type-C vertical breakout downstream connection board. So this is a breakout board. You can plug a USB-C cable into it that's coming from a computer or a battery, something like that. And then this can be used to drive your project. If your project needs either just 5 volt coming over the USB, you can use that. Or you can get data over it and use it as a nice convenient way to plug a USB-C connection into your project that has a microcontroller connected to this here, or could even be a single board computer. We've got the essentially USB 2.0 connections on there. So there's a V-bus, a ground, a data minus, a data plus. Those are the key ones you need. And then this also has some of the fancy USB-C stuff that lets it determine what kind of power to ask for. So by default, with the 5.1K resistors on CC1 and CC2, this will ask for 5 volts up to 1.5 amps if the thing you're connected to can supply it. A couple things. Let's go to a view from the web page here. I'll refresh this. Good. We still have them in stock, so I know we stashed a bunch before the show. Thanks to Jelly and Travis and the new products team for that. Took the price and cut it in half, so you can see it's $1.48. You can get up to 10 of them per customer. And you can see it here plugged into a breadboard. So this is a nice way to use it. It has 2 rows of identical pin-out header pin pads there, so you can solder headers onto it. It comes with some male header pins. Plug it down into your breadboard, and it's going to be mechanically stable. It's got all the pins there that you can plug into. And since this is a symmetrical design, you can even be above the break in the breadboard, no problem. So if you need to, for some reason, you're not going to short anything. These are all essentially pin compatible vertically, straight up and down like that. So a couple other things about the board here. It's a USB-C plug. So that means you'll take something like a USB-C cable like this, plug it right in, boom. This is going to be on the device side, or what is somewhat confusingly, I believe, also called the upstream facing side. So this faces the upstream thing, which is going to be your battery power pack, your wall wart, or your computer. This is the device side of things, so the downstream side of things where you've got your microcontroller, essentially. So you can plug in USB-C cable to that. The other end is possibly a USB-C, could also be USB-A. It's serving that purpose. So if you have that kind of cable that's A on one side and C on the other, that would work fine plugging into something like your computer. And the way I've used it here, I'd love to show you a little demo. So I've taken one of these and I've soldered it into a little perma-proto board. So you can see it there. It gives me a nice vertical connection on a perma-proto board where you can see a horizontal connection like the original connection on this Pico here. You can't really get to it when you're buried into an enclosure, but this is a nice one. We could drill a little hole and file out a slot there if we wanted to have the cable just plug in from the top, but I'm just using this as a little portable Pico dev board here. I can also solder on some female header pin rows here so that I can plug into it kind of like a breadboard. But for now, what I've got on there is the vertical Breakout. It is connected to the Pico's USB data and ground. So there's T2 and T3, or data minus and data plus, on the pad side of the board. I'll show you that in a second. And then there's also a USB ground that's right there, very close by all of that to keep things nice and clean. And then into V-bus, we've got running on the V-bus of the Pico and the V-bus of the vertical Breakout. So you can see here, I'll go ahead and plug this in. This is power and data coming from my computer. And ka-chunk, plug that in. You'll see I've got the LED blinking there and then holding still once I've plugged it in. And this, if I head over to my code view here, I'm actually not showing code. I just wanted to use this as sort of a notepad because what I have this doing is acting like a little USB keyboard macro rubber ducky kind of thing. And it's just this one button. When I press that, you'll see it's acting as an HID device that just types out a message. So here it says, "Welcome to Pico in an Altoid tin with a vertically mounted USB-C Breakout. My mind is blown." So that's all it's doing, is just when I press this button, it types out that little message for us. So nice, neat, contained little gizmoid there, and when I'm done with it, I can just unplug USB, close it up, no holes necessary in the case. If I wanted to, I could put it into the top, which is kind of nice for this type of application. Another application that you'll see this type of vertically mounted board used on is things like front panels. So if you have a box, think of like a, I don't know, a game console. You might have a USB plug that goes right in the front. These are actually pretty nice to mount given the 4 mounting holes that are built right onto there. You could screw those right into the front of a faceplate on a case, and then a small hole. You can use a couple of drill holes and a file, a small saw and a file to make that little oval slot in there. And then that'll allow you to have a plug-in connection from the front. Same thing with synthesizers. There's a lot of forward-mounted things like Eurorack modules, modular synthesizer panels where you want to be able to just plug a thing in if you're trying to do some sort of data firmware update, that kind of thing. So I love this, really great design, very cool, and thanks to Liz for putting this together and also doing the search for this particular shape and design of vertical mount USB-C. I believe it's a, is it through hole to the bottom side? It's got, you can see it there actually on that picture. It's got mechanical connection onto there. It might be a surface mount for the actual data pins. I'm guessing that's what it is. But there are 4 sort of through hole, partial through hole mounts there just to keep the whole package from separating from the board. So it's on there nice and strong, so you don't have to worry about it. You can plug and unplug to your heart's delight. Let's see, what else? Any questions over in the chat? Todd pointed out in the chat, this is the Permaproto mint tin Permaproto that I'm using there. I used some very strong adhesive, so it's actually difficult to pull this out of the board. Let me see if I can, just so I can show you the underside, and then I'll flip over that Pico as well. So let's go to this view here for a second, and I'm going to refocus a little bit there. So these are just almost, I'm using these just as like a grip. I can probably even pull up on the, do they want to come off? Oh my gosh, they really don't. All right, so just imagine you're going to see a proto board with the bottom side of those pins soldered in. Since I said I would show you what's going on with the Pico, I actually used some header pins so I could socket that in there. And you can see I've got, get in closer there. So I've got 3 small hookup wires connected to these 3 pads, T1, T2, T3, and that's what gives us ground, data minus, and data plus, and then I just can tuck that away there. I made those a little long so it was easier to manage, and that'll just plug right back in there, and there we go. So here you can actually see this nice up close. Let me focus on the board itself. Here we go. So USB-C cable providing power and data. Plug that in, and off it goes. Much more convenient, and I'll be honest, a lot more sturdy than a micro B connector. These things are notorious for lifting right off of boards. Particularly, I think in that orientation, you just tend to whack the cable and off it goes. So this vertical orientation is really nice and handy, and you can see it's less likely to have damage when the cable gets wiggled. The other thing I want to do is head over to this view here, so you can see that's got the TP1, TP2, TP3 pins or pads up at the top. That's where USB connection is. The other board that you can use this with is, without needing a sort of intermediate cable, is the KB2040. So if you look at our keyboard board, this has D plus and D minus. Oops. D plus and D minus right here. Those are the data for USB 2.0. And then you'd use ground and I think I can't remember which one. It might be raw is the 5-volt, essentially the V-bus connection there. So that allows you to just easily break out those USB connections and go vertical if you needed to. So that's another option there. All right, let's head back to product there. There's also a nice shot of it in semi vertical view. Let's see. I think that covers it. Let me know if you have any other questions in the chat. Otherwise, we'll move on. See, Tyeth says, I've not slept enough and it's late here, but where was the 4th wire going to the Pico? Thank you for asking. I didn't explain that well. If you look at this view of things, get it in good focus. The very top right pin there, right in this kind of orientation, is also V-bus. So it's one of those rare cases where the silkscreen names match up V-bus to V-bus. So you can see here, V-bus on the Breakout is this little red wire going to V-bus on the Pico. That one's not broken out as a pad underneath as far as I know, so I just used the proto board to do that. So this is not something that you can easily, connect and disconnect since it's not an actual pin that's socketed. But if you need, it's a $4 Pico. So if you need to set one of these up like this, it's sort of semi-permanent. Plug it in and solder it, and off you go. Is that called pin 11? Oh, it's pin 11 on my Perma Proto. It's probably pin 40 on the Pico, or 39, something like that. By the way, another little trick I did to make this useful as a little mobile hacking platform was printed out a nice big pinout for myself of the pinout on the Pico because there's no silkscreen on the top. So this is just one of the default SVG files for the board here, and these are little pin labels that Toddbot created on. He has a little sort of sticker you can put right on top of the Pico that just has these nice pin labels for things like the GPIO pins and ground. It doesn't break out and tell you what's got PWM or SPI or all that stuff. The bigger pinouts do, but this is nice just for having the pin GPIO pin numbering that we use inside a CircuitPython or an Arduino. And you know what? Since I showed it in action, I might as well show the code that I'm running on here for anyone who's curious. If you haven't done simple HID keyboard stuff, this is a nice introduction to it, I think. So let me go to the IDE again, or the code view, and I'm just going to open up code.py that's sitting on the Pico. So you can see here I'm using the USB HID and HID keyboard key code. I'm using keypad just to read this little button press here. And then the main event here, when I press a button, the keypad event checker sees that it's been pressed. If it's been pressed, I'm doing keyboard layout right, and then my message. And this was my message, welcome to Pico, yada, yada, yada. So if I just put a little space down here and make myself a neat place for typing, when I press my little button, it will do a little bit of typing for me there. So that's a basic use of something like this as potentially something like a keylogger or a macro for typing some setup scripts if you're doing some machine maintenance, network things, can be useful. And the way this is set up on the proto board, you could run a whole lot of buttons because I've got buttons here that will run from one pin to that ground rail there. So you could probably fit, I don't know, 5 or 6 of those across the bottom without too much problem. Same on the top. So now you've got a bunch of little macro buttons, that type of thing, just in a little mint tin. Let's see, any other questions? Thanks for that one, Tyeth. I think no. All right. I think that'll do it. So let's wrap things up like so. And that right there is my product pick of the week this week. It is the vertical USB-C Breakout. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. See ya.